Hello students, in this lecture we will see one of the most important concept in statistics, that is probability. Before going to see the definition and examples of a probability, let us see some important definitions and some important concepts required to define a probability. First one is a random experiment. What is a random experiment? Random experiment is an experiment or any operation, any phenomenon, any process, any experiment, any event which has possible number of outcomes is called random experiment. Which has possible number of outcomes is called a random experiment. In random experiment, outcome cannot be predicted with certainty. We cannot predict the outcome with 100% or with probability 1. Or now we are going to see some examples of random experiment. We have seen any operation which has a possible number of outcomes is called a random experiment. What are the random experiment? Tossing a coin. Then we have outcomes head or tail. This is the outcome, H or T. Second one, rolling a dice. Dice has a 6 faces numbered from 1 to 6. When we roll a dice, we have 1, 2, 3, 4, 5, 6 outcomes. 6 numbers and we will get 1 number on the uppermost face of the die. So this is the 6 outcomes. Third one is appearing for an examination. So when a student appears for an examination, then his result, pass or fail, is the outcome. Fourth one, drawing a card from a pack of 52 cards. So many such examples can be given, which has a possible number of outcomes, is a random experiment. Now, next concept is sample space. Sample space is nothing but the set of all possible outcomes of the experiment or of the random experiment is called a sample space. Sample space is denoted by capital letter S. For example, in an experiment of tossing a coin, sample space is S equal to, when we toss a coin, then we will either get a head or a tail. That is, it is denoted by H or T. Second one, in a random experiment of rolling a die or rolling a fair dice or rolling a dice, we have the sample space S is equal to, we will get a number 1 or 2 or 3. So this sample space is 1, 2, 3, 4, 5, 6. Out of these 6, we will get 1 number on the uppermost face of the dice. So this is the sample space for the experiment of rolling a dice. Third one, appearing for an examination. What is the sample space for appearing for an examination? Appearing for an examination, if a random experiment is what? A random experiment is appearing for an examination. So what is the sample space? Appearing for an exam. The sample space, in this case, sample space is pass or fail. Pass or fail. So pass, fail. This is the sample space. So many experiments and examples we can take. So I think you understand the concept of random experiment and sample space. Next one is sample points. Sample points. Sample points means each outcome is called a sample point. The possible outcomes in a sample space Often in a sample space of a random experiment is are called sample points. Sample points are pass and fail here. These two are the sample points. The previous example 1, 2, 3, 4, 5, 6 are the sample points. Head and tail are the sample points. And number of such sample points are denoted by n of s. The number of such sample points, n of s is what? This is the number of sample points. Often sample points number of sample points of an experiment. For example, here n of s is equal to 2. For example, n of s is 2. For the previous example, here n of s is equal to 6, and here n of s is again 2. Okay, this is the number of sample points. Now we are going to define event. Event. What is event? Event is any subset of sample space S. Sample space S is called an event. Any subset of a sample space is called event. For example, in the second experiment, random experiment is rolling a dice. So sample space S is equal to 1, 2, 3, 4, 5, 6. So take any subset of this sample space. Suppose I take a subset E. E is equal to set of even faces. That is, we will get on the uppermost face of the die, we will get even number. So that this is equal to 2, 4, 6. Getting an even space is our event. Set of even faces. This is an event because this E is a subset of the sample space S. E is contained in S. So this set of all numbers 2, 4, 6 are the elements of S. This is one example of. Second, you will get A is equal to set of all odd faces, or getting an odd face. Odd face means what? On the uppermost face of the die, we will get odd number. That is, out of these 6, we will get odd number 1, 3, 5. 1, 3, 5. These are the odd numbers. So this A is again contained in S. Therefore, A is an event. So similarly, this E is also event. E is event. Event means this is a subset of a sample space. Event is nothing but a subset of a sample space. Suppose this is a whole sample space denoted by S. Then this A. Suppose this is a whole sample space S, and this is A. Then this A is an event. Then this A is event. This is event. Event is a subset of a sample space. Now we are going to define some more terminologies in this regard. Okay. First one is mutually exclusive events. Mutually exclusive events or impossible event and certain event. First one is impossible event. Impossible event means what? We already know that this phi empty set phi is always contained in S, always subset of S. This empty set phi is called impossible event. Therefore, this empty set phi is called impossible event. Impossible event. Phi impossible event. Or an event which does not happen is called an impossible event. Similarly, certain event, certain, which is certain to be happen, certain event. 100% guarantee that this event will happen. Certain events here, this S is a subset of S here. So this S is a subset of S. S is an event. This S is called a certain event. This is called a certain event. So out of these n outcomes, one outcome may happen. So this yes always happens. So this is called a certain event. Now we are going to define a complement of an event. Complementary event. Complementary event. See here, this phi is an empty set. This is called impossible event. S is again a subset of S. This is called certain event. Now we are going to see complementary event. Suppose A is any subset. A is any event. A is any event. Any event means what? A is a subset of this sample space S. Suppose A is here and this is the sample space S. Then this part, in this part A will happen, and this part is called complementary event of A. This part is called complementary event of A, and this is just S minus A. S minus A, and this is denoted by A complement, or this is again denoted by A bar. A bar is what? A bar means A does not happen. That is called A bar. A bar means what? If A does not happen, then that is called A bar. If A is any event, then non-occurrence of A is called a complementary event. Non-occurrence of an event A is called a complementary event of the event A. It is denoted by A complement or A bar, or it is again denoted by A dash. It is again denoted by A dash. So this part is a complement. So this part, this shaded part is an A complement part. So inner part is A. So, okay. Now we are going to define some more terminologies. Mutually exclusive events. Mutually exclusive events. Mutually exclusive event. Mutually exclusive. Two events A and B are said to be mutually exclusive if A intersection B is equal to phi. Their intersection is empty. A intersection B is equal to phi. Such an events are called mutually exclusive events. For example, if you want to take an example, suppose here S is equal to 1, 2, 3, 4, 5, 6. So let us take A is equal to set of all even numbers 2, 4, 6. And B is equal to set of all odd numbers 1, 3, 5. So A intersection B, is there anything common in A and B? No. A intersection B is empty set. In A and B we have no element in common, so A intersection B is empty. Therefore A intersection B is empty means what? A and B are mutually exclusive events. mutually exclusive events. Then here S is equal to 1, 2, 3, 4, 5, 6. What is A bar? A bar is B here. Here A bar is equal to, that is A does not happen. That is A will not be a, we will not get a even number on the uppermost face of the die. So A bar is what? See here, this is whole your S. This contains 1, 2, 3. So and this is A. A contains 2, 4, 6, these numbers. So A bar is what? This contains 1, 3 and 5, these numbers. So this is your A bar. This is your A bar. So A bar is equal to 1, 3, 5 and this A bar is B here. So these two events are mutually exclusive events. And similarly, what is B bar? B does not happen. B bar is again A. B bar is 2, 4, 6 and this is A. So these two events A and B are mutually exclusive because their intersection is empty. Next we are going to define exhaustive events. Exhaustive events. Exhaustive events. So here two events A and B are said to be exhaustive. Two events capital A and capital B are said to be exhaustive if A union B is equal to yes. A union B is equal to yes. That is, the two events A and B is equal to S. This is S here. Suppose this is A and this is B. So union of these two, then we will get union of these two A and B is S. For example, A is equal to 1, 3, 5 or 2, 4, 6 getting an even face in a random experiment of rolling a dice, and B is equal to getting a odd face 1, 3, 5. So A union B means what? All the numbers from A and B are taken together forming a union. So we will get 1, 2, 3, 4, 5, 6. How will you get this union is equal to 1, 2, 3, 4, 5, 6? We will get A union B is nothing but this is the union of all elements from A or B. So 1 is in B, so we will take an here. 2 is in A, we will take an here. 3 is in B, we will take an here. 4 from A, we will take an here. So this A union B is equal to S. So A and B are exhaustive events for the random experiment of rolling a dice. So these two events are called exhaustive if their union is yes. The last terminology, equally likely events. Equally likely events. Last one is equally likely events. Equally likely events. Equally likely events means what? The two events capital A and capital B are said to be equally likely events if probability of occurrence of two events are same. If probability of occurrence of each event is same. Probability of occurrence of each event is same. For example, if we have n event, that is getting a number is one event, getting 2 number is an second event, getting a 3 number is an third event, getting a 4 number is an fourth event. Similarly, getting 5 and 6. These all events, singleton sets events, these are the singleton sets events or equally likely events, or they are equally likely outcomes because probability of occurrence of 1 and probability of occurrence of 2 is same. The probability of occurrence of 1, 2, 3, 4 each and every sample point is same. Such outcomes or such events are called equally likely events. Hope you understand. In the next lecture we will see actually the definition of probability. Thank you, students.